All right, so today we are going to be reiterating what we've talked about for our values of a and b. So remember, yesterday we said anytime you have some value a at the front of your function, then that means you multiply your y by the a value. So multiply y by a. And anytime we have a term b inside of our equation, that's going to affect our x's. And we divide our x values by b. The reason we do that is because a is telling us what we call the amplitude of our function. The amplitude is your maximum and minimum's distance from your x-axis. So typically, our maximum and minimum are 1. But if we have some value a that we multiply our y values by, that 1 and negative 1 could change to something bigger, like 3 and negative 3, or something smaller like a half and negative a half. So our amplitude is just whatever our a value is. Of course, the absolute value of a, because remember, a negative sign is going to cause the function to reflect. That's not going to affect how far up or down we travel. Your period is typically always 2 pi, but like we've seen, that can change based on our value of b, because if I divide my x values by some value bigger or smaller, then that's going to change the length of our period. So to find your new period, you take 2 pi, the original length of the period, and divide it by b, which is exactly what we've been doing to all of our x's, divide by b. So here it says to graph y equals 4 times sine of 1/2 x, and they asked for the amplitude and the period. Well, according to this information here, my amplitude is the value of a. My a is 4. The absolute value of 4 is 4. Therefore, my amplitude should be 4. To find my period, it says that we take 2 pi and divide it by our b value, which here appears to be 1/2. We don't like to divide a fraction by a fraction, so we keep, change, and flip, which is going to give us 4 pi. So our period should be 4 pi. So let's plot those points and see what happens. So we know that sine starts at 0, 0. Its next point is at pi halves 1. Its following point would be at pi 0. Next point is at 3 pi halves negative 1. And then our end of our period is at 2 pi 0 on the parent function. So now we're going to apply these changes. So we said for our x values, we're going to be dividing by a half. So here I'd have 0 divided by a half. Well, 0 divided by anything is still 0. Here I'm dividing pi halves by a half. Again, we don't like a fraction in a fraction, so I'm going to keep, change, flip. Here my 2's are going to divide out, which is going to leave me with pi. Here I'm going to have pi divided by a half, or pi times 2 over 1, which would give me 2 pi. Here I'll have 3 pi halves divided by a half, or 3 pi halves times 2 over 1. My 2's divide out, and I'm left with 3 pi. Here I'm going to have 2 pi divided by 1/2, which we already did up here, and we said that becomes 4 pi. For my y values, I'm supposed to multiply them all by 4. Well, 0 times 4 would still be 0. 1 times 4 is 4. Again, 0 times 4 would be 0. Here, negative 1 times 4 is negative 4, and 0 times 4 would be 0. So I need to go plot these new points to see if these things are true. So my first point is still at 0, 0. My next point is at pi 4, which would be all the way up here. My next point is at 2 pi 0. My following point would be at 3 pi, but that's not going to fit to the right of my graph. Luckily, we just need to plot one full cycle, and our function is repetitive. So not only does it continue to the right, it can also continue to the left. So I'm just going to go plot the other points of my cycle to the left. So I now would need a minimum, and then I would come back to a 0. So my function looks something like this when we plot one full cycle. So it does appear that from our x-axis that my graph went up 4 units and down 4 units, which does give me an amplitude of 4. And it does appear that since it took from negative 2 pi to 2 pi, my period was a length of 4 pi, which is exactly what we said. So keeping that in mind, if I look at this next example, it gives us the picture and they ask us to write the equation. Well, remember the amplitude is how high I have traveled from the x-axis for my maximums and minimums. Well, here it looks like I went down 2, and over here looks like I went up 2. So that must mean our amplitude is 2. Now for my period, looks like I traveled from here to here, which appears to be from negative 2 pi to 2 pi. So this would have been 1 pi, 2 pi, 3 pi, 4 pi. So our period must be 4 pi. And now that I have that information, I should be able to write my equation. So my equation is going to be y equals, I always start with the amplitude. If I'm looking at my graph here, it looks like on the y-axis, which is where our first point usually is, was down here at negative 2, meaning I had a minimum. So that means it must not be sine, it has to be a cosine graph. However, cosine does normally start at a maximum, which would have been up here, but it appears to have a minimum, meaning my point was reflected down here. And we discussed yesterday that if our points have been reflected, that must mean my function is negative. Now I know the period, but I don't know my b value, which is what's supposed to go after cosine. But according to this information here, we find our period by having 2 pi over b. So 2 pi over b should equal the period, which we found to be 4 pi. And I'm just going to solve for b. So I'd want to get b out of the bottom of my fraction by multiplying both sides by b. And this is going to leave me with 2 pi is equal to 4 pi times b. And then I would just divide both sides by 4 pi. The pi's divide out. 2 over 4 simplifies to 1/2. So my b value must be 1/2. And then we have our x. All right, we got one more example here. And it says to give the amplitude, the period, and the equation. So for this information, we should have had a sketch of our graph. So I am going to provide you with the amplitude and the period so that you can then sketch your graph and give the equation. So the amplitude is going to be 1.5, while the period is going to be 4. So for my equation, I'd have y equals 1.5. We're going to make this a graph of sine. And then I would plug in b. Well, again, I don't know b, but I do know 2 pi over b gives me the period, which I just told you to be 4. So I'm going to solve exactly like we did earlier. And when I divide, I'm going to have 2 pi over 4, which is going to simplify to 1 pi over 2, or pi over 2, and then my term x. So since this is a function of sine, it's going to start at 0, 0. And normally, I would go up to 1 for my next point, but I have been asked to multiply my y values by 1.5. So for all of my points that were originally 0, 0, pi halves 1, pi 0, 3 pi halves negative 1, and 2 pi 0, we need to make our adjustments. So for all of the x values, we have to divide by our b value, which we found to be pi halves. So here I'll have 0 divided by pi halves, which would still be 0. And for the y value, I'm multiplying by my amplitude 1.5. 0 times 1.5 would still be 0. All right, here I'm going to have pi halves divided by pi halves. Or, in other words, pi halves times the reciprocal, 2 over pi, which is going to give me 2 pi over 2 pi, which is equivalent to 1. So this became 1. Then I multiply my 1 by my a value of 1.5, so that becomes 1.5. Then I have to take my pi and divide by pi halves, or in other words, pi times 2 over pi, where my pi's divide out, and I'm going to be left with 2. And then 0 times anything stays 0. Then I'm going to have my 3 pi halves divided by pi halves. So really 3 pi halves times 2 over pi. My pi's divide out, my 2's divide out, and I'm left with 3. And then negative 1 times 1.5 would be negative 1.5. And then lastly, 2 pi divided by pi halves, or 2 pi times 2 over pi. My pi's will divide out, and I'm going to be left with 4 pi, and my y value will stay 0. So now I'm going to go plot these new points. So my first point is at 0, 0. My next point is at 1, 1.5. My next point is at 2, 0. Our next point is at 3, negative 1.5. And my final point is at 4, 0. So my graph would look something like this.